All right, so let's go back to our trig integrals and review this. So remember, the only time that we use our half angle formula is when we have cosine squared or sine squared. So when there's odd powers, we never use the half angle formula. So it's only when they're even powers only. That's the time we use this half angle formula. So I'm not going to show any examples of that. If we have sine and cosine combinations, odds and evens, or just odds powers, remember what we do is we work the u substitution backwards. So we start with sine x dx or cosine x dx, and this is the identity that we make work, right? So we use this, not the half angle formula, when we're making the good du. So here we go. So here I see cosine cubed. Remember, we want to leave even powers. So I'm going to take off one of the cosines, peel it off. There's the cosine of x dx is a good du. So u is sine. So if u is sine, this will be taken care of, and this will be taken care of. So I just need to rewrite cosine squared as the identity, 1 minus sine squared. Remember, not half angle formula, this identity. So now make the u substitution work. Cosine of x dx is du. Put the u in for sine, u to the fourth, 1 minus u squared. Multiply it out, integrate it, and then put the x's back in, and plus c. All right, here we go. So sine cubed, it's a good idea to pull off one of the sine of x to be the du. Then u would be cosine. Oh, but wait a minute, there's a negative issue, right? So this is where I suggest you let u equal cosine. The du would be negative sine, but put the negative on this side. Then there'll be no complications with you having to square or cube a negative with the, usually don't let u equal negative if there's no negative in the problem, right? This is the easiest way to make sure you don't make mistakes. This is the identity I want to use, right? Because I want to change this so that u equal cosine works. So sine squared is 1 minus cosine squared. So put in the u of cosine, 1 minus u squared. Replace sine of x dx with negative du. Take the time to pull the negative outside. Take the integral of 1, which is u. And then I multiplied the negative through. And then I put the x's back in. So this one here, cosine cubed, I would peel off a cosine of x. Then the u would be sine. Oh, this is nice and easy. If u is sine, I just have to change cosine squared to 1 minus sine squared. So 1 minus u squared du. Take the integral of 1. It's u again, correct? Then replace the u's with the x's. Okay. So moving on to something more challenging. So now I want to talk about a w substitution before the good du. Okay. Like this one here. So cosine cubed of 4x. I'm going to suggest that you start with a w substitution of 4x. So dw is 4 dx, so I get 1/4 dw is dx. So take out dx and put in 1/4 dw, and then put the w in, so I get cosine cubed of w. Now go through the process of making the good du. So peel this off. That's my good du. There's my u. Use this substitution in w's. Remember, as long as the angle is the same, it works. So now cosine squared is 1 minus sine squared of w. And then cosine of w. Remember, you want to go from one letter to the next, right? All x's, all w's. Next, all u's. 1 minus u squared du. Take the antiderivative. That's a u. That's a u cubed over 3. Then put the u back in. So the u is sine of w, and I'm just going to put the w back in as I go. So just comparing, right? So if this one here had 3x inside, I would suggest that you do a w substitution of 3x. Then dw is 3dx, so I can put the 1/3 outside, have it all in w's. Now make my good du. There's my good du. So u is sine of w. So then use your identity and then rewrite everything in terms so that my sine of w will work. This will work. Cosine squared just needs to get replaced with 1 minus sine squared. And the cosine of w is ready to go with the du. There's my du. There's my sine. And then cos 1 minus u squared. Make sure you multiply this out first, integrate it, and then put everything back in. One more example here. So sine cubed of 5x, do the w is 5x, dw is 5dx, so 1/5 dw is dx. So here is everything in w's. Now make the good du, peeling off the sine. So peeling off the sine, so that's my du is sine of w dw. So what's my u going to be? Oh, negative issue, right? So I'll say u is cosine, and I'll put the negative out here. So I want to make my u as cosine work, so I'm going to change sine squared as 1 minus cosine squared. And so then 1 minus u squared, sine of w gets replaced with negative du. I'm going to take the time to pull that negative on the outside, then take the integral of 1, which is u, integral of u squared, which is u cubed over 3, then put the cosine of w back in, and then put the w's back in.